Hello everyone, I'm Dr. Priya Hassan and welcome to AstroCon. Today we are going to talk about comets because this month we actually had a comet visiting us. So let's first talk about comets and see what they are all about. Now, comets are actually cosmic refrigerators for the simple reason that they are frozen balls of ice. And first of all, let's say that the word comet means wearing long hair. And a comet is actually a small frozen body which, when it approaches the sun, it gets heated up and produces a long tail, two long tail rather, because there's a dust tail and there is an ion tail. But we'll talk about that. So the coma or head of the comet, which you can see over here in the figure, is its nucleus, and the tail of gas, you can see there are two tails which are being expelled, and this is basically because of solar radiation that it gets expelled, and you have these beautiful tails being coming out. Now, comet nuclei vary in size. They could be quite small, from several hundred meters to tens of kilometers, and they consist basically of ice, dust, and small stony fragments. So the coma maybe reach about 15 times the diameter of the Earth, while the tail could actually be like 150 million kilometers. So it's huge. So a comet is sufficiently bright and close, may be observable from Earth, unaided by a telescope, and therefore when people saw comets, there were various folklore in various cultures about comets, and comets were usually considered bad omens, deaths of kings or normal men, or coming of catastrophes, or various things. Now, comets often, they have highly elliptical orbits and therefore they could have very long periods. You could also have short period comets which originate from the Kuiper belt, that's basically between the orbit of Neptune, right, beyond the orbit of Neptune. While the long period ones, they come from what is called the Oort cloud, which is further away, right. Now, there are about 5,000 known comets, and however, this is only a small fraction of the comets which we think there are. There should be about 1 trillion comets because they are this thing. And then we talk about comets that have been visited by various space probes. For example, NASA's Deep Impact or Rosetta. So, like I mentioned, the solid core of the comet is the nucleus, and it's composed of rock dust ice. It could also have frozen carbon dioxide, carbon monoxide, methane, ammonia, and often they are called dirty snowballs, and their surfaces are formed of dense crystalline ice mixed with organic compounds, while the interior is colder and less dense. So, therefore, they've been proposed as possible carriers of life because they could actually have methanol, hydrogen cyanide, formaldehyde, various amino acids with which it could actually transfer through. So, here you can see a very beautiful picture. This is with Hubble Space Telescope of the comet Ison shortly before perihelion. And if you see that in the outer solar system, the comets remain frozen and inactive. But when they come close to the sun, that's when you basically have the tails appearing, okay, because of the material that gets vaporized out of them. Now, we also know that there are comets outside our solar system, which we call exocomets. They've been detected. The first exocomet was detected around Beta Pictoris, and a total of, we know about 11 such exocomets, but obviously there will be much more. Like we said, a comet is heated up in its passage, evaporating its icy components, and actually after some time what happens is the comet gradually breaks up, right? So if the Earth's orbit sends it through that tail of debris, then there's debris left over there, and that debris itself is what leads to what we call meteor showers, okay? And therefore the Perseid meteor shower, for example, which occurs sometime in August, it's basically when the Earth passes through an orbit of comet Swift-Tuttle. While Halley's comet is the source of the Orionid shower, which is in October. Now, many comets and asteroids collided with the Earth in its early stages, and there's also a theory where scientists think that a comet about 4 billion years ago, could be the one which actually got the last quantities of water which we see on the Earth, which is very important to life itself on Earth. So it's not just bringing life, but it could be possibly even getting in, water on the Earth. Now, the speed at which the comets enter the atmosphere combined with the magnitude of the energy, they could allow molecules to condense into larger micromolecules that can serve as the foundation of life. So in 2015, scientists found significant amount of molecular oxygen in a comet 67P, suggesting that the molecule may occur more often than had been thought. And it is suspected that even comet impacts not only on the Earth, but it could have happened even on the Moon, and that could have led to water on the Moon, and now which is now lunar ice. And the nucleus of some comets can be fragile. It could be so. For example, there was a comet called Shoemaker-Levy 9, which was actually discovered in 1993, and a close encounter in July 1992 broke it into pieces. And over a period of 6 days in 94, these pieces actually fell into Jupiter's atmosphere, and we have beautiful images of it actually falling on to Jupiter. So this is an image which you can see over here, and these brown spot marks are basically the impact sites of Comet Shoemaker-Levy on Jupiter. You can see this is another comet which has been broken down. This is called Schwarzmann-Wachmann within 3 days, and you can actually see it beautifully broken down to pieces. 1995. Then Halley's Comet in 1910. Now comets are basically named as per different conventions. Earlier it used to be the year it was in. For example, the Great Comet of 1680 or the Great Comet of this thing. And for example, when Halley demonstrated that the comets of 1531, 1607, 1682 were the same body, because he noticed that there was a periodicity, then it got named Halley's Comet after the discoverer. For example, we have Encke's Comet, Biela's Comet. These are all named after the astronomers who actually discovered them and calculated their orbits. Now, later on, it often became the convention of naming comets was after the discoverers and also the instrument of the program. So, for example, in 2019, astronomer Gennady Borisov, he observed a comet and it was named 22L Borisov after him. Now, you can see in this, we have Deep Space Impact actually got high resolution images of Comet Borrelli, and Deep Impact actually plastered a crater into Comet Temple. This is Comet Temple, where it actually did a crater to actually see its composition, and it basically suggests that the majority of comets' water rises below the surface, and the reservoirs feed the jets of vaporized water that form the coma of Temple 1. Later on, this was renamed as Epoch 1, and it made a flyby of the comet Hartley 2 in 2010. Now, in 2007, the Ulysses program, it actually passed through the tail of this comet, Comet C 2006 P1, and the Stardust mission, it actually studied the tail of Wild 2. It found that it was crystalline, could only be born in fire, and checked the comet spectra. The Rosetta probe, ESA, the European Space Agency Rosetta probe, it actually orbited the comet Churyumov-Gerasimenko, and its lander, Philae, it actually landed on the comet's surface, which is the only one which actually landed on a comet's surface. So you can see here some very beautiful pictures. There's the picture of Neowise in 2020. You can see the tail is huge. You can actually see it so beautifully. This is another one, which is Comet C 2006 P1 from Victoria, Australia. You can see you have two tails. This is Comet 1882. And then attempts were actually made to look at comets with X-ray. So this is an image actually of an X-ray image of a comet, Hyakute, which is with the X-ray Rosat satellite. And you can see the structure of it, the nucleus, etc. Here you have another image of an active asteroid studied by Pan-STARRS, where you can see not one but multiple tails. These are basically made of different composition, and hence they get pushed by different amounts and resulting in multiple tails. Here's a beautiful picture of the comet Siding Spring, imaged by Hubble, the original and the processed one. And then we had the WISE Space Telescope, which is an infrared telescope. And you can see that there's a mosaic of 20 comets which were discovered. It discovered a large number, and you can actually see the comets over here. If you look in yellow, yeah, the images in yellow, these are the comets which were discovered by Neowise between 2013 and 2017. Here is the Stereo-Solar Observatory, which filmed the comet Lovejoy moving against solar wind. Beautiful, you can actually see it. Here's the comet, you can actually see the comet beautifully moving. This is in December 2011. And therefore, various studies have been made of comets. They are very interesting objects. And in the next bit, I'm going to tell you about our visitor we had in October 2024. So, thank you so much.